Thank you. First, I would like to thank all the attendees, and of course, a special thank, like I always do, to all the students from all our ports. The next topic is going to be about the sustainable fishing, technology for sustainable fishing by Pascal Larnaud. Pascal Larnaud from Lorient. So let me first introduce Pascal, if you don't mind. I'm going to read his little bio. So Pascal Larnaud is an engineer in the fishing technologies at IFREMER, a French maritime research institute. Pascal is a managing director of the Lorient site, IFREMER. He is also the project manager, marine biological resources at the Sea Innovation Cluster in Brittany, France. That cluster is called Pôle Mer Bretagne Atlantique. And as I said, Pascal is a part of the Propeller Club of Lorient, managed today by Dominique Deschamps. So as for the precedent presentation topic, any question you can add them or write them in the chat box or in the QR also box. So Pascal, let's go fishing.
Thank you very much, Annick, and good afternoon, everybody, and or good morning for some of you. And thank you for your invitation, Mr. President, and thanks also to my friend Dominique Deschamps, who is the president here of the Propeller Club in Lorient, and to Annick to have organized and proposed my name for this presentation. First of all, I would like to apologize for my rather poor English, I would say, and I will do my best to make me understand and to understand your question. So I'm going to try to connect and to share my presentation. So do you see it?
Yes, we can see it.
Yes, okay, all right. So just 1 second. Okay, it will be better for me to look at you. Okay. Okay, so sorry, excuse me. So I'm going to speak about technology for sustainable fishing, and the content of my presentation. Sorry, I have a small problem there. Oh, I will have to. Sorry, I want to look at you, but to this screen it will be better for me. So, excuse me. So you see here on the slide the content, and so I will make a small introduction about IFREMER and about our topic today, and we'll speak after that about selectivity of fishing gear, and the different ways to reduce physical and carbon impacts and to make fishing more sustainable. And I will make a short conclusion. So IFREMER is a French public industrial and commercial institute under the joint supervision of the Ministers for Research, Marine Fisheries and Agriculture Environment. And so we are, excuse me, I am going to put the time to see where I am. It will be better if I forget to put it. It's there, chronometer, that's okay. All right. So we are 1,500 people, and our budget is 230 million euros. IFREMER is composed by five big centers from north to south of France that you can see on the map, from Boulogne-sur-Mer to La Seine-sur-Mer in the south. And I'm speaking to you from Lorient here in southern Brittany, and our headquarters, roughly half the people of IFREMER are based in Brest. It was in Paris before, but today it's in Brest, in Brittany. What else? Ifremer is operating the French oceanographic fleet, all the French fleet, and which is composed by 11 vessels and different ROV, remotely operated vehicles, autonomous underwater vehicles, etc. Right, and we have 18 stations from north to south of France, and sites, stations, it's our French name, but sites from north to south. And also we have centers or in the world in Saint-Pierre and Miquelon that you may know if you live in the States, and Martinique, French Guiana, Réunion Island, and New Caledonia. So Ifremer has a broad spectrum of activities and skills to conduct interdisciplinary scientific and technological research. It is firstly a research institute, and also to conduct scientific expertise and monitoring in support to public policies. So as I said, Ifremer operates the French oceanographic fleet and manages the major and national and international research infrastructures. And of course, Ifremer tries to collaborate with blue economy companies and make transfer of technologies to innovate. And also another challenge is to open science to society. Our institute is based on 23 research units organized in 4 scientific departments. The first one is biological resources and the environment. This is my department where I am involved in. And the second one is physical resources and deep sea ecosystems, so all the deep sea systems, observation and everything. Oceanography and ecosystem dynamics, and also the last one is more technical on research infrastructures and information system. You can see on the picture the different, in fact, 30 years of scientific survey tracks. So you can see that Ifremer is involved in all over the world. So coming to our topic now, so in a short introduction, I can say that a lot of innovations have been done in fisheries since the 50s to fish more until about, I would say, 1985, and towards it moved to fish better with an amplification since 2000. Particularly on selectivity improvement in particular. And in the context, we have the fluctuating prices of fuel, which is, as you may know, is very important and fluctuating. And the share of fuel in the operating account of trawlers particularly is very important, and they are always seeking for better economic balance. And we are living in the global social constraint, of course, very important to reduce the environmental footprint. And but we always have to consider our work in global sustainability, including the socio-economic aspects. This is, of course, very important. And we have the driver of EU Common Fisheries Policy, which has 2 main points: MSY. I will come back on this concept. And also landing obligation. It's simply speaking, it's you are obliged to land all that you catch on fishing boats. Of course, it's not so simple, but that it has been a strong driver to improve selectivity from 2013, something like that. So now coming to selectivity, some generalities. So when you want to catch fish or crustaceans or everything, of course you will find them in the water column from the bottom to the surface, and you will have to choose and to adapt your way to fish all that. And so what is selectivity? In fact, it is the fact to select the species and the size you want to catch. So I'm going to detail more of that. So to catch all these species, you can have what we call passive gears and also active gears. But passive gears can be traps, can be lobster traps, for example, or long lines, or some lines, for example. And considering active gears, You can have simple gears such as a harpoon, for example, when you have to move your harpoon to catch or to kill a fish, for example, as you can see on the first picture on the top. And you can do yourself selectivity when you do that. So you can choose the species and the size and decide to catch it. But of course, it can be applied to all trawls, all types of trawls, both on the bottom trawls, or in the water column, what we call pelagic trawls, etc., and others. So we have two types of selectivity. The first one is, I would say, interspecific, between species. So the idea is to catch, to avoid to catch non-targeted species. For example, emblematic species such as turtles or dolphins, for example. But it can be also when you want to catch shrimp, to avoid to catch fish. You may know that it's a big problem all over the world, and we can improve that. Or in France, we have nephrops, scampies, that we can catch without catching fish, for example. It's another way. We want, in that case, to preserve biodiversity. And the second type of selectivity is intraspecific selectivity. In that case, you want to let escape juveniles of commercial species and other species that you don't want to catch. And generally speaking, it's you want to let grow the small fish to become bigger and to make the stocks of fish grow. So I want to very shortly to explain you, maybe you know that, but this concept of MSY. Firstly, of fishing effort. Fishing effort is very simple. It's a number of boats that you will put at sea to catch fish, or it can be the days at sea, it can be the number of traps, of number of nets, etc. So this is fishing effort. And I'm going to show you, to try to explain the MSY, which is maximum sustainable yield. So you have here a typical curve of fishing stocks with the effect of the fishing effort. You start from nothing, you reach a peak. I can try to put, yes, maybe you see my mouse. No, I can do it there. Maybe it's better. So you can see here a peak. And after that, if you continue to increase fishing effort, to have more boats and etc., you will have a decrease of the quantity of production of the stock. And even if you have more boats, you will have less quantity to share. So your part will be smaller. So, and that's what has done the fishing policy in Europe. So it was to break boats, as we can say simply. So to decrease the fishing effort. This is the first reaction. We had this situation. And you decrease your fishing effort to come back to an optimized production. And this maximum production of a stock is there, and it's called MSY. This is the maximum sustainable yield. And why am I speaking about that? It's because it is linked to selectivity. So very simply, you can see here, for example, the blue curve. This is the same than before. We at simply, it's age 1. You catch fish at age 1. The second one here would be only if you decide to fish at a bigger size, so to catch fish only at age 2. And the pink one will be at age 3, and the last one, the green one, will be at age 4. So all these curves show you decide to increase the commercial size of your fish. It can be done, it's a mandatory decision. So as you can see, at the same fishing effort here, with different selective profiles, in fact, you decide to fish bigger fish, with the same effort, you will improve selectivity and you will increase the MSY, which is here the maximum production of the stock. Here, in fact, for the same fishing effort, you increase the MSY by 80%. And even in the last case here, when you decide to fish a really bigger fish, you can even increase fishing effort here and go further and improve again your MSY, and which is the the cook, the part of the meal that you could share, if you want, the cookies that you could share. I'm looking to Dominique with behind me now. Okay, so some selective example about selectivity. The first one is in the Celtic Sea. It's what we call T90. So what is T90? If you, I think that, wait, yes, can you see me? Yes. So you have here a piece of net, and when you, so this is a piece of net of a trawl, and when you have the drag in the trawl, when you tow the trawl, the water will push the nuts and the twine, and you will close the meshes like that. The meshes will be closed. And T90, what is T90? In fact, I turn my meshes by 90%, like that. And in that case, you will see that I can't close the meshes. And it is much more selective shape of meshes. And I will speak a little bit about also, so I have turned by 90 degrees. If I turn only by 45 degrees, I obtain this, which are square meshes. Okay, so this is what I have just explained with T90. Okay, so we put this type of meshes, open meshes, in the end part of a trawl so it's roughly the real length is something like 12 to 15 meters, and you have at the end the cod end where the fish is collected. And it's a sort of a cylinder, 1 meter, roughly 1 meter, 1.2 meter wide. So we carried out this test in the Western Brittany, and with the technique of twin trawling. In this part of France, in the Bay of Biscay, and we use commercial trawl are often twin trawling for nephrops, for example, but other types of species. And it's very easy for us because we can have one trawl which is a commercial trawl equipped as a commercial trawl, and the other trawl can be equipped as a selective trawl. In that case, with a T90 in the end of the trawl. And during the trials, of course, we can change. We put change the side to have something very objective, very significant results, because you can have an effect of the side of the trawl. So the results here were, you have here the mean. In fact, it is the mean for standard trawl and select trawl. Do you see my mouse when I move it? I suppose, yes, okay, all right. Here you have the quantity of fish per hole, in fact, per hole. And so you can see here that for landings, you have no difference between standard and selective. You have here the standard deviation, and here the mean. I don't go in details, it's not important. No difference in landings. But in discards with this T90, you can see here the standard trawl and the selective trawl. And so you have a great reduction of discards of 50%, as you can see here. It's very significant. And if we look closer to specific species such as boarfish, which is considered as discard, but it's a problem for us because it is in the regulation of landing obligation, because Irish people have some quotas for that, and I forgot to say that landing obligation is for species under quotas. And here with this boarfish, so as it is under quotas in Ireland, we are obliged to discard them, and we would be obliged to bring them to onshore to land them. So it's not very good for fishermen because they have nothing to do with that. And here you have the example in images with the standard trawl. Here's the result of the standard trawl here on the left, and here the selective trawl. So in fact, the decrease here is 86%. And you can see here the results. You have the length here with 13 centimeters, 16 centimeters, and here's the quantity caught for each length. And you can see here the selective trawl in blue, and in red the standard trawl. So you can see the very big difference here also on this scheme with the selective trawl here. So it's very efficient to avoid to catch this fish. Same thing for small haddocks. It's very, very interesting, this one also, because there is a very significant reduction of discards, 94%. This is here, but it is also a commercial fish. Haddock is for us a commercial fish, and here the fishermen try to catch rather big haddock themselves in this area. And you can see here that the same probability of catch is 42 centimeters, which is okay for these types of activity. And it is, you can find it here, you have 40 centimeters, 42 here. And after that, you have no loss, no commercial loss, no difference between the selective and the standard trawler. But here, you can see the huge difference and the huge decrease of discards. So another small example only to show you that it's with square meshes that you can recognize them on this picture. There's the square meshes. And only to show, so it's a cylinder. It's much shorter. It's only 2 meters long, but you can. It's only to show you what could happen. I hope that you will see this small video. I hope that it's okay. So you can see really what is selectivity. The small fish escaping through the square meshes, and they wouldn't escape through standard losange meshes. Okay. Okay, I'm going on. And the last example for that is for the nephrops fishery, another type of selective device, which is a grid. It's a type of screen, if you want. We put it in the trawl, and the idea is to let small nephrops, small scampies, go through the grid. And in that case, so we have been working on this type of grid for a long time, maybe 20 years, but now we have the grid which is able to be selective and also to resist to the handling on the drums on the commercial boats, you know, which is not dangerous too. So it's a very, very efficient. So it is articulated. And so here you have the results. It's you know this type of scheme now, and you have here the length. It's the length of the head in millimeters, and here you have the commercial size, and you can see here the difference between in red you have the standard trawl, and in blue you have the selective trawl with roughly 35 to 40% decrease in discard. Of course, the challenge is to less as much as possible to lose the lower commercial quantity as possible. It was improved since these results. So I'm going on a little bit on selectivity to speak to you about to talk to you about the ways to improve selectivity, some new ways to improve selectivity. So we have a project which is quite common in France. We call it Game of Trolls, and it is managed by my colleague Julien Simon, very good guy. And so the idea of this project is to use artificial intelligence and to improve trolling with very new techniques. So first of all, we can consider that at the entrance in front of the trawl. So the idea here is to let enter only the species of interest, and we can also reduce the impact on the seafloor. And in our study case here will be bottom trawls targeting nephrops. So I can maybe I will show you this. This is not done on the trawl, but it's done on a sledge. But we should have the same videos. We have a very important survey on nephrops. So you can see here nephrops. In fact, you have all that you can see here is small burrows. Nephrops, scampies live in burrows, and the trolls will catch only nephrops which are on the seafloor, in opposition to traps, for example. And so I send it again. I launch it again. Sorry, and we make thanks to artificial intelligence, we make the difference between nephrops. We identify nephrops and make the difference with what we call Galatian, which are close to nephrops, but which are not commercial species. And it works. So starting from that, the idea is to have, in this type of trawl, to have the camera here. We have stereoscopic cameras, 2 cameras, which are able to give 3D images. And why 3D? Because 3D, as our eyes, will give us the possibility to have the size. So it is very important when we are trying to improve selectivity to know the species and the size, of course. And so we have a computer which is embedded, and so we have the computer on the troll. Here you have motors which can make the troll move. You will see that in images. I hope so. We have removed the protection here. It was written by my colleague Julien. And here, I hope that you will be able to see this short video. You have the system. So we put light because we only want to observe and catch only what we want to catch. So you can see here what we call the ground gear, the ground rope. And maybe I will come back only to show you that again. It is lifted here, and we will only put it, drop it on the bottom when you have something to fish. Okay, and I think we should see it lifted again. And it's very quick, and it can be managed by the skipper, but it can also be managed by the system, the automatic system with algorithm and some motors that you have on the troll. Okay, so I can stop it here. Next one. So you have the same, it's very short, but you see here, this is okay, you see it, and it will lift again. The action is it goes very fast, okay? And we have time to observe, to make video, to treat the signal, and to fish the animal. And here you can see what can happen at sea. So this is the same system, but at sea. It is still a model, and you have it on the ground here on the bottom. And we will decide to raise it. Okay, it is raised. Okay, so this is some new techniques using artificial intelligence. And the following case is there to when you are inside. So we are inside the extension, the end part of the troll. So in this case, you catch everything. You could, of course, add the first system in front of the troll, but you could have both. But here we are only in the troll. We catch everything, and we want to sort species in the extension. So the study case in that case is more a pelagic troll, but I can show you videos. Only this one will show you. I think yes, you can see some fish. It is a deep, it's a bottom fish. Okay, so you can also observe bottom fish, identify them, and make the troll decide what you are going to catch to keep or not. And so the case of pelagic troll is very interesting. We are here with this image is very clear, but we are in the troll with some white diffusion around. And here you can see sardine and horse mackerel. And we make the difference between sardine and horse mackerel. And the idea, when you have a mixture, you could open your troll, for example, and let everything, if you want only sardine, for example. You have the decision, or you can make the programmation of your computer to decide itself what you want to keep in the troll. So this is what can do in artificial intelligence. You identify each fish. You can measure it with two cameras with 3D vision, and also with some laser rays, which could give you the distance. So in that case, we can really identify separately sardines and horse mackerel. And after that, we can have different devices, such as this one. You have here square meshes on the top. Under this square mesh panel, you can see here, you can move the piece of net with small meshes that you can have in the troll. And if you want to lift it, so you put it like that, the fish come in, you don't want the fish, you will let this piece of net drop, and you will let the fish escape. And after that, if you want to keep fish, you will lift this piece of net and avoid to lose fish. All right, so last thing about selectivity, it's light. Is the light able to improve selectivity, the use of light? So we tested that in North Sea and in the channel in the Celux project. And we used the safety net Pisces lamps. It's a LED lamps that you can see here. And so we tried many things on the top, on the bottom, and so the best results were obtained on the bottom. We are here in our flume tank in Orient, as the previous videos or pictures that you have seen. So here you recognize the square meshes on the top, and the idea is to what we have observed is that whiting, for example, was pushed by the lamps to the top, and we tested also another twine, phosphorescent twine, which is manufactured by the French company Le Dresden. This twine is called Braise Glow, and here, for example, you have no light; it is in the dark, and you have the phosphorescence of the part on the bottom, and here you recognize the square meshes on the top. And we have observed the behavior of the fish. And the result was that for whiting, it was the main species that we wanted to observe, but not only. For whiting, we have noticed a tendency to repulsive trends on whiting, both for green lamps and also for Braise Glow phosphorescent twine by night, because the result is stronger by night. But the results were quite viable, during the season, because it seems that there is a seasonal effect because of light intensity, because of turbidity, etc. And we have a wide field of experimentation all over the world. All the fishing technology team in the world work on that, and we have a specific group on that, an international group. So we have a wide field of experimentation to use light in different situations. I can show you a short, I'm looking time, a short video of herring, for example. Yeah, and here you have the light on the top, and you can see herring escaping through T90 meshes, open meshes. Maybe wider. Okay, for herring is more attracted by light. And here's some video for whiting. You have less fish, but you can see. So in that case, the lamps are on the bottom, and you can see whiting, which is pushed to the top, and which is going to escape through the T90 meshes. All right. And my last slides about selectivity is, in fact, to make it to approach selectivity in a broad sense. In fact, you can also make selectivity before catch. We have seen that when you put observation in front of the troll and combine it with artificial intelligence. But you can also use acoustics. And the very huge development in acoustics, in echo sounders, in sonars, and the software treatment also improved a lot the treatment of signals and the quality of the signal. And you can have a better idea today, mainly in pelagic trawling, but you can have a good idea of the species that you have before. In front of your boat, if you want, and about this, and also so both on the species and also on the size, and you can decide to fish or not to fish. And also, if we are speaking about selectivity before catch, we could speak also about acoustic deterrence that we have developed on common dolphins. With the idea there is it is a directional pinger. You put it. If you have the troll here, the pelagic troll with very large meshes in the aft part, and we put the directional pinger there. We send the signals there, and the idea is to make an acoustical barrier in the troll to avoid that dolphins enter. And it's really efficient. And we have a project which is still going on this, but it's very efficient. Of course, there is many years of work on the signals and the arbitration of dolphins and all that. It's in great progress. And also, we could speak about gear shift. Sometimes, very often, you can hear, oh, we should use long lines instead of troll, for example, or you should catch nephrops with traps instead of troll. So it can be done. It can be done, but what I want to say about that, you have this type of fish pots, for example, nephrops traps or long lines. when you do that, when you want to think about gear shift, you have to really to make very heavy studies about with an approach on bio, techno, socio-economical. You need to have a technological, sociological, and economical approach to analyze the situation and to know what is better for the stocks, for the bottom, etc., and for economy, of course. And also, an issue about all these type of devices, they need baits in the pods, in the traps, on long lines. You need to put baits, and most of the time, baits are caught by trolls. Okay, so we have to think about all that when we decide something. And this is an example. Also, all these techniques have to need nearly management because if you put too many traps, for example, or too many pots, of course you will have problems. We have the same problem for MSY than with trolls. If you need to manage your activity, whatever activity, fishing activity it is. And the last solutions important for when you speak about selectivity in a broad sense, it's the area closures at certain time periods, what we call spatial temporal closures, and it can be done for juveniles or areas where you have reproductive animals, for example, and it can be mandatory or voluntary. And today, the fishermen have more and more of voluntary selective behavior. And this is important, of course, to improve fisheries in the world. About what I have said, all that I have said to now, there is one evidence. All proposed solutions must remain economically and socially acceptable to be sustainable. Of course, we have to think always think to this tripod of sustainability. And now I will conclude my presentation with speaking about the reduction of physical and carbon impacts. So here you have different types of troll doors. You know, these doors are done to open the troll, to make the horizontal opening of the troll. Here you have a quite old design, but which is still used in Lorient fishing port. We still have on small boats this type of doors. They are quite impacting. You can see they raise the resuspension of sediment is on all the height of the door. So here you have something which is more with a better design, with some computerized design, you know, and you can see you have foils on the door, and you can see that the sediment resuspension is much lower. And on this third one, you can see what we call the jumper. We have designed this door. It is what we call the jumper door. So we have modified the gravity center, and when it touch the bottom, it will jump. You can see that on the video. I can put it again if you want. So this is our jumper door. It is not already used because we have some. It's a large door. It's not already used on the private vessels for the moment. But we have tried to develop other solutions. So it was designed in front tank with a computerized modularization, and we developed that with a Morger company, which is quite famous by the fishermen in France and in the world too. They were often copied. And here you have this is on a private boat, the trials with this another design of this jumper door. And so the results were that we had 50 to 90% decrease of the resuspension thanks to this door compared to quite good doors, but more classical. And the last design that it's still going on project. You see the images, but it was tested efficiently at sea. You see it's on bottom troll. It's in our front tank. You have a bottom troll here with the ground gear here, the ground rope, and you have the doors are lifted. So this reverse project, carried out also with Morger company, had the objective to develop doors lifted from the bottom, and of course still able to catch fish. It will not work on all species, but on most of the species it will work. And I can speak also about the impacts and finish. This is the last topics that I will reach today. It's the fuel consumption, mainly on trawlers. On a trawler, 2/3 of the fuel consumption is used to tow the trawl. 1/3 is only for the boat, for cooling, for everything, for and the light and everything. Two-thirds are used to tow the boat due to the drag of the trawl. And on the 2/3 for this trawling operation, you have 10%, roughly 10% for the cables, 30% for the doors, which are there, and 60% for the net part. All that was calculated thanks to a software dynamite that we have developed to modelize all types of trawls. And you can save energy at each level, of course. And so this is what I was speaking about, is this modeling, and with this dynamite software, which enables you to design your trawl, to modify it, and you have to have a precise plan of the trawl. Of course, you have to put the diameter of the twine, the sizes of the meshes everywhere, and etc. But when you have done that, you can optimize the geometry and everything, and save fuel. A lot of fuel, sometimes 20% and even more. And it was very useful in Britannia region to help fishing industry. And for 37 minutes, so I'm going to my conclusion. So simply speaking, I would say that everything is linked. Selectivity, drag, impact, fuel consumption, security, quality, everything is linked. When you want to improve selectivity with larger meshes, or thinner twine, for example, you will improve firstly the quality, because you will, when you let escape small fish, or when you let escape small nephrops, they won't be there to create, to generate a mechanical constraint for the other species between themselves, and so you will have less quantity in the trawl. So the quality will be better. And also on the deck, you will have less quantity to sort. And when it is on the sun in the summer, it can be very damaging to the quality. So selectivity can help to improve strongly quality. And larger meshes can also decrease the drag. You will decrease the drag if you have less twine in the trawl. And larger meshes. Less meshes, less twine. And when you decrease the drag, you decrease the force needed for traction of the trawl. So, of course, you can decrease your fuel consumption and save energy. And what is very interesting too, it's when you decrease this force needed for traction, will also decrease the contact force needed on the bottom. In the aft part of the trawl, the ground rope can be smaller. You can make the ground ropes lighter. You can also make the doors lighter, because you will have less drag, you will have less drag behind and need less force to tow the trawl. And so you can have lighter ground rope and smaller doors sometimes. So, and you can decrease impact on the bottom, improve security, because everything is lighter, so it's always better for selectivity. It's smaller, it's better for selectivity. You have to know that doors are something very dangerous on a trawling boat, on a trawler. And also, of course, in that case, you will again save energy. So all our job today on trawl is summed up in this scheme. And this is, so considering trawling in any case, you can consider that, so this is what could be sustainable fishing. And so I could have spoken about many other things, of course, and about the biodegradability. We are working on the biodegradability of even trawls today, but I could have spoken about laser trawl. For example, it's done by Icelandic colleagues. It's very interesting too. And maybe unteds, maybe excluder devices for turtles, for example. In the States, I know that you use that, and we use that. We have developed that also in French Guiana. So, but I had a limited time, and I hope that it was interesting for you. And thanks again for your invitation and for your attention. And I will try to do my best to answer to your question. Thanks.
Thank you. Thank you, Pascal. Very nice presentation. I have a question. Maybe you can see it, or you want me to read it to you? It's about, I'm going to read it.
Yes, I prefer. Thank you.
What challenges do you have in getting fishermen to adopt this technology, and how does it affect their operating expenses and yield?
Okay, so it's a good question, of course. So it's always first thing we have to involve fishermen in our trials. From the beginning of all our projects, they come very often to our flume tank. It's very important, and we involve fishermen in our project. So this is the first thing. And we are very often brainstorming in the project, quite every time in all of the projects, we have brainstorming with the fishermen to let them speak, and also to let them propose some devices. On these devices, sometimes we test devices proposed by the fishermen. So this is very important. And of course, we have to consider the economical point of view. So very often we include in our project the economics colleagues and which are very close to the fishermen, and to calculate really what will be the reality when it will be implemented on board.
Okay. No more questions?